So in section 6.5, we're going to talk about complex numbers in polar form. But really, if we're going to talk about that, I should talk about complex numbers in general, and for that matter, imaginary numbers, because the introduction to this stuff, which kind of sucks anyway, in this book, is back in chapter 2, and we don't cover chapter 2 for reasons. But what we should think about here is those imaginary values, and to get the idea of imaginary values, I want to give a little bit of historical context. So back in the 17th century, there was a lot of understanding that had yet to be found in terms of math. That is, there were a lot of things that they didn't have then that we have now that fill out some details that haven't yet fully been understood. And in particular, there was a lot built around and made of the idea of the real numbers, the counting numbers, the decimals, the irrationals, the values like pi. There's a lot made of that, and you see the word real number to kind of imply that it is all that we need of reality. However, there are a lot of situations where we don't get all that we need of reality in that way. For example, something like x squared equals -1, by definition, can't be solved with just the real numbers. Well, the mathematicians of the time said, hey, that's inconvenient, but we don't need it, so we don't have to care, but we should still call it something. And as a result, mathematicians like Descartes, we talked about earlier, had the idea to call these things imaginary. In particular, Descartes said in his work on this at the time that these quantities are sometimes only imaginary. That is, one can imagine as many, as I said, in each equation, but sometimes there exists no quantity that matches that which we can imagine. And thanks to a combination of historical inertia and a respect for his other work, the name imaginary number stuck. And unfortunately, it kind of set the expectation that the imaginary values don't have any meaning in the real world. See, like I said, when bad things happen in math, you can blame the French. But as time went on, as we spent more time working with these things, we found that it's not just an inconvenience that equations like this get solved by numbers that are outside of the real. These values actually do have meaning. And as Gauss would later suggest, that maybe we shouldn't be calling them imaginary because it sets the idea in expectation that they're nonsensical. He suggested that instead we call these lateral values, so that we have the meaning there that they're sort of off to the side, but they are real. But we have what we have because we have what we have. It's important to know here that when it comes to these things, there really isn't the sort of manna from God thing when it comes to mathematical notation or even any real math. It's the result of a lot of work. And sometimes that work doesn't lead to places that are useful for people who are struggling with the basics when it's written by, people who aren't struggling that much at all. Anyway, that's the idea here. When we're talking about imaginary numbers, don't get too caught up in that name. Because just because they have the name attached to them, imaginary, it doesn't mean they are irrelevant or in any way having less bearing on real things. Just know that when we're talking about them, we're talking about things like the square root of -1, and we call that I, meaning the imaginary unit. It is a thing of real value, just not real value in the mathematical sense. It's a strange phrase to say, but it's one that I do have to say here. And with this idea of the imaginary number, the imaginary unit, came work into things called complex numbers, where, in general, a complex number is something of form z equals a plus bi, where it has the real part a and the imaginary, again, we don't love that name imaginary, but that's what we call it, part b. And in doing this, in describing things in terms of both what is real and what is imagined, as it were, in the mathematical sense, we get some interesting results. And I suppose this is where I would say that the term imaginary does kind of carry a bit more weight, because really you do have to have a little bit of imagination to understand just what's going on when you're talking about graphing things like these. You get some very strange kaleidoscopic looking behaviors, even for the simple things, and that's without starting to dig into some of the more complex stuff that's going on with the complex numbers. Hey, the name does kind of fit. But that's what we'll be looking at here, is some of these types of values, how we can represent them, their meanings, their presentations, and some of the algebraic manipulations that we can do here, specifically in the context of their representations using sine and cosine.